In this episode, Binomial Theorem, episode 2, coming up, back into action. Hey guys, today I will show you how to expand the binomial by using the binomial theorem. And for the first episode, you could check out my playlist where I did more simpler and more easier example with binomial coefficients and Pascal's triangle. Now, expand basically means you need to open up, you need to remove the parentheses and rewrite your expression without any brackets or any parentheses in it. So notice that your first term is 2x. So it's including these two, the coefficient in front has to be taken into consideration. And your second term, it's not 3, it's negative 3. So also this negative sign has to be taken into consideration. So let's write out the expansion. So you simply write the first term, which is, as I said, 2x, and you are going to raise it to that power that you are given. Let's call it n. In this case, it's 4. So you are going to raise it to the 4th power. This term gets multiplied by the second term, which is negative 3. So if you are given positive number, any positive number, so you simply just multiply it by whatever you are given. So, and the second term is going to be raised to the 0th power. So you always start for the first term with this highest power that you are given, that appears in your problem. So in this case it's 4. And second term, you just always start with the lowest. So you start not with 1, but with the 0. And this product gets multiplied by a binomial coefficient. It's a number that basically, in this case, using the long tail brackets, it's 4 choose 0. Sometimes it's written in the way n choose a number, n choose r, or n choose k. It's just different notation, which basically means the same, the binomial coefficient. So, moving on, plus the next term, so it's going to be 4 choose 1 for the next term, to x is going to be raised to the 3rd power, so we are going to decrease the power for the first term by 1. We are going to reduce it by 1. Whereas for the second term, which is negative 3, we are going to increase power by 1. So instead of 0, I will write 1. Next term, 4 choose 2. Also notice for these binomial coefficients, so the top number, it's always that highest power, n, which is 4 in our problem that you are given. The bottom number, it's kind of counter. It's every time runs from 0 all the way up to 4, all the way up to n. So term 2x second power and negative 3 to the second power. Also notice that if you adopt the powers, so it's always adapt to this 4. 4 plus 0 gives you 4, 3 plus 1 gives you 4, 2 plus 2 in this case adapts to 4, always. Now, we have some more. Let me just drop it down over here. Plus 4 choose 3, and you would have 2x first power and negative 3. We are going to increase. And finally, the last term, 4, choose 4, to x 0 power and negative 3 fourth power. And we are done with that expansion. We write it down. Now all you need to do is just simplify it down with algebra. So the first thing that might come to your mind is how to figure out how to work out this coefficient. There are two basically ways. You could either use the formula for binomial coefficients, which is basically, let's say, n choose r, and it's n factorial over r factorial n minus r factorial. So where n factorial is basically the product of all natural numbers from n all the way down to 1. So n times n minus 1 times all the way down to 1. And basically by definition 0 factorial is just 1. You could either use this formula or you could use a Pascal's triangle. It saves you time and it's kind of faster, but basically completely up to you. So for Pascal's triangles, we always start, so another way. We always start with 3 ones on the edges. We keep moving these ones. And we are going to add these two numbers above. 1 plus 1 gives you 2. So keep ones outside. It gives you 3. 3 outside. 4. 6. 4. 1. And so on. You could go on with more rows. So since we are given the fourth power, we are going to use this row for our expansion. So I'm going to grab these coefficients for my expansion from this row. So this is 0, 1, 2, 3, the fourth row. This is the fourth row. So I'm going to grab those numbers. Now, let's clean it up. So the first coefficient is basically 1. The second one is going to be 4 from Pascal's triangle. The next one is going to be 6. So this is 6. Next one 4. And the last one is just 1. So notice the binomial coefficients, they're always kind of symmetrical, so you have ones from that side, it's kind of mirror image, fourth from that side. Now, this term, anything raised to the 0 power gives me just 1, and we could simply ignore this term, and we could simply ignore this term over here. And you do this algebra, you need to raise 2 to the 4th power, so it basically becomes just 16 x to the 4th. Moving to the next term, you have this 4, keep it. So, like we did over here, when you raise something to the power, so be careful, pay attention that you need to raise both. You need to raise this number coefficient to the power, and you need to raise this variable to the power. So 2 to the 4th, 16, right? And x to the 4th, x to the 4th. So, because some people forget about raising the number to the power, so that's extremely important at this point. So, likewise, 2 gets raised to the 3rd power, cubed, 2 cubed gives you 8, and x cubed. And you have negative 3 from here. Now, moving on to that term. It takes lots of space, I know it looks like messy, but it is what it is. So, for the next term, our binomial coefficient becomes 6. So 2 squared gives you 4, x squared left over, and minus 3 squared gives you just 9. So all we need to do after just multiply through these numbers. This term from the binomial coefficient, 2x to the first power is just 2x minus 3 raised to the third cubed. It's gonna be negative, be careful. The odd power gives you negative numbers. So negative 27. And the last term. So this is 1. This is 1, so we could simply ignore these two terms. And negative 3 raised to the 4th power. So it's basically positive 81. So plus 81. And I believe the last step, just clean it up. So 16 x to the 4th. Now you do this algebra, minus 96 x cubed from the second term. Now, if you multiply 6, 4, and 9 through, so you would get plus 216 x squared. From here you would have the same number, 216 x and plus 81 left over. So that's one is gonna be your final answer for that problem. Alright, so just again a few things to keep in mind. If you are given not just term, not just x, not just variable alone, something like 2x, 3x, 5x, so make sure that you take it as a term and raise it together with the coefficient in front. That's extremely important, like I did. So 2x, 2x, 2x. If you are given not plus a number, or instead you are given minus a number, so this minus you take it, since you're going to add all of these terms according to the binomial theorem. So because this negative, when you raise to odd power, basically your term becomes overall negative. So these little things, I know it is tedious and it's lots of bunch of algebra work involved, but just the way it is. Anyway, I hope it was helpful. Thanks for watching and train your brain. I know everyone hates math, but if you like my video, please hit like, share with your friends, leave the comment down below, and be sure to subscribe so you will not miss out my new videos.